Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Periodic acid HIO4 cleaves vicinal diol and polyol systems. Each C to C bond between two carbons each bearing an O or is equal to O equivalent is cleaved. The products depend on the carbon's substitution. A terminal CH2O gives HCHO, formaldehyde, an internal CHO gives CHO, formic acid, and HO, aldehyde end gives CHO, formic acid. Reaction: I. The compound is arabinose type structure, 2 vertical bar, CHO, 3 vertical bar CH2O. This is a 5-carbon open chain aldopentose, example, arabinose. It has 5 carbons total. Carbon 1, CHO, aldehyde, cleaved to give CHO. Carbons 2, 3, 4, each is CHO, internal, each gives CHO. Carbon 5, CH2O, terminal, gives HCHO. So formic acid from reaction, I, is equal to 4 moles, from C1 as CHO and C to C3 C4 as internal CHO. Moles of HIO4 consumed is equal to 4, consistent with 4 HIO4 given. Reaction to the compound is CH2O vertical bar, CHO, 4 vertical bar CH2O. This is a 6-carbon open chain alditol, sugar alcohol, example, sorbitol mannitol. It has 6 carbons total. Carbon 1, CH2O, terminal, gives HCHO. Carbons 2, 3, 4, 5, each is CHO, internal, each gives CHO. Carbon 6, CH2O, terminal, gives HCHO. So formic acid from reaction, 2, is equal to 4 moles, from C to C3 C4 C5. Moles of HIO4 consumed is equal to 5, consistent with 5 HIO4 given. Ratio is equal to moles of formic acid in I. Moles of formic acid in 2 is equal to 4 divided by 4 equals 1. Why other options fail? A. 3/4 would imply 3 moles in I. Incorrect since the CHO carbon also yields formic acid. B. 4/5 would imply 5 moles in 2, which is not the case since the 2 terminal CH2O groups give formaldehyde, not formic acid. D. 5/4 would imply more formic acid in I than 2, which is not the case. Therefore, the correct answer is C. Therefore, the correct answer is option C.